So I thought I could help you a little bit when we're talking about composite figures, volume and surface area, because they can be a little bit confusing. But composite just means put together. So if we have two shapes, these two cylinders, we could put them side by side, we could stack them on top of each other, we could really do anything, and it's composite, as long as it's two shapes that we put together. With surface area, it's not quite as simple as just adding two formulas together, because we have some space that we don't need to count when we're talking about that. So here we have this blue cylinder stacked on top of a red cylinder. And let's pretend that they're glued together for this lesson. And you can say, which sides can we actually touch when we're looking at this? We can touch this bottom side. We can touch the surface around. We can touch the top of this, and the side. But we don't have the bottom of the blue cylinder, right? So we don't need to count that. So we know the formulas for all these, but now we just need to add them together. So the formula for the top of the blue cylinder is just pi r squared. We know that, the area of a circle. The area for the side of the cylinder is 2 pi times the radius times the height. And the same with the top of this is going to be the radius squared times pi. But we're going to have to subtract this blue circle from the center of this, right? Because it's like we cut out the top of that red circle. So it's like a donut shape now that we need to talk about. So we have the radius of the blue circle and the radius of the red circle. So as long as we subtract the blue from the red, then we're going to end up with the top of this red part. That'll be our answer. And then we also need to count the side of this, which is just 2 times pi times the radius times the height, and then the bottom of the red one. Let's pretend like that's solid. So it'll just be the area of a circle, which is pi times the radius squared. So now all we need to do is add those together. So the surface area is just going to be circle, side, donut shape, side, circle, all those added together. Let's say that we need to figure out the volume of this shape. It's a little bit easier, actually, than the surface area. Now we pretty much just need to add these two together. So remember that for the volume of a cylinder, it's just pi times the radius squared times the height. So let's say this is radius 1, and this is radius 2 for the red cylinder. So the area of this whole figure is just going to be pi times the radius 1 squared times the height, and then plus pi times the radius squared times the height of this. So that would be the volume. Let's say that we have to figure out the volume of this. It's just a donut. So now what do? We have to take this part from this. So the first thing we want to do is figure out the volume of the whole thing, as if there were no hole cut out, because that's easy. So we know that's pi times the radius squared times the height. So we have that, but now what about this part? Let's say that we have the radius of this also. We know the radius. So all we have to do is subtract that volume, right? It's just like we did for the surface area of the top of it, but now it's the volume. So let's say this is radius 1. So we're going to subtract that part from this. So it would just be, we can write it down because it might make it easier. You can say it's pi times the radius squared times the height minus pi times the radius squared times the height. And let's call the big radius radius 1 and the little radius radius 2. And that's going to give us our answer for the volume of the whole figure. And we should make sure that we never get a negative answer, right? Because it would never make sense to get a negative volume. So if you accidentally subtracted the big volume from the small one, then you would get a negative answer. But you'll know that's wrong. So you'll just do it the other way around. So make sure you're subtracting the small volume from the big volume.